Good morning, one and all. Welcome to the session Product Design on Mobile Lab. Today I will be introducing you the problem statement and our solution to the problem statement. Before I talk about more on the problem statement, let me introduce you some of the test and measuring devices which we generally use in the laboratories. The laboratories I am talking about as an engineering perspective, not as an industry perspective. In engineering, particularly the circuit branches like electronics, telecommunication, instrumentation, or the core branches, electrical engineering, or the allied branches like computer and IT branches, where they will be using some of the test and measuring equipment for conducting some practicals, also some mini and major projects. The subjects are like, right from the first year engineering itself, they are supposed to do some hands-on sessions on basic electronics and electrical, digital electronics. Maybe in second year, including in computer IT, they're supposed to do some electronic devices and circuits. And electronics and telecommunication and electrical students perform some practicals related to analog circuits, network theory, linear integrated circuits, and so on. At the higher semesters, including computer IT, they have subjects related to embedded systems, that is called cyber physical systems, design with microcontrollers for various applications. And nowadays we have the subject called Internet of Things, which is an emerging field which is going to replace our conventional traditional communication systems with the Internet of devices, right? Internet of Things. Things means devices. Now imagine five to somewhere between 5 to 7 subjects, almost all these branches. Even these things are there. Even in mechanical engineering, they have a lot of automation, robotics applications. So I would say almost there is no field or branch left where automation is not done, right? So keeping in mind the trends, the futuristic products, software in hardware, and smart devices are almost everywhere. So now that's the reason why these branches are upgrading the subjects, are adding these electives in terms of software hardware partition, even in these core subjects. Like we have seen how the 3D printers have replaced these traditional electromechanical things. So it's the need of the hour. All right. So the equipment what we generally use in the laboratories are, to begin with, let's say a oscilloscope. Earlier we used to have a cathode ray tube, CRO, cathode ray oscilloscope. Now almost we have replaced with the digital storage oscilloscope, DSO. So what for we use this equipment is, as you can see, instead of using cathode ray tube, now we are using this LCD. And there are, you can see, inputs, what we call as a channels. So if you want to display any waveform, right, whatever is the nature of the signal you would like to see, that signal we give it as an input to these channels. Right now this oscilloscope is a 2 inputs oscilloscope. So whatever is the signal you would like to see, it could be a mechanical like vibration signal, or it could be a biomedical instrumentation like ECG, EMG, and so on, or it could be electrical like voltages, currents, or power signals you would like to see, or maybe in telecommunication you would like to see modulation, amplitude modulation, frequency modulation. Any type of electrical signals which is coming from either from the circuits are coming from the sensors. You would like to see them. So that's the reason why we use this oscilloscope called digital storage oscilloscope. We are saying digital storage oscilloscope is because it has the ability to store the signal. As you can also see, externally also you can save it, right? There is a pen drive where you can insert it and you can transfer the signal. So what you can see, the options is there are some potentiometers are there. By adjusting these knobs, you can adjust the amplitude of the signal, whatever you are displaying. That is x-axis and y-axis. The way you zoom it on your mobile phone, your picture, right, by touching the screen. Similarly, by rotating these knobs, this X and Y scale factor, you can increase or decrease, either multiplication or division, that you can do it. So that is the scaling you have, what is called time scale and the amplitude scale. So there are two ways of displaying the signal. One is what we called as a time domain signal. Second is called frequency domain signal. In the sense, this x-axis you want in time or you want frequency, right? So there are two possibilities. As you can see, there is a button called FFT, right? That means if you want to display the signal in frequency domain, that means x-axis is representing frequency, then you can go to this option called FFT. Otherwise, traditionally, we want to display x-axis as a time, y-axis as an amplitude. So that is where these two knobs, this and this. So this is for your scaling of this time, and this is the scaling of the amplitude. You can do it. So since two channels are there, so both the channels individually you can control the amplitude of the signals. There is a trigger signal is there, where if you want to display the waveform, a stable waveform on screen, so that signal should be triggered. That means the sweep generator should be triggered with reference to what? This X or Y, so that has to be decided. What is that magnitude of the input that you have to select it from the trigger signal. Similarly, you have other options, that is, as I told you, there is a inbuilt facility for storing the waveform and analyzing the waveform, measuring the signal, and so on. So all those things are available here. So basically, a CROs you get based on this, as you can see, the bandwidth, right? For example, this is 100 megahertz. You get 50 megahertz, 20 megahertz, even the up to you get even 500 megahertz is available, which is expensive things. Similarly, the sampling rate, how many samples you would like it can take per cycle is also it's mentioned here. And of course, this is a colored. That means when it is displaying the waveforms, that is the channel 1 and channel 2, it will display in two different colors. So that means your screen is in a color form. Alright, so this is the most common measuring equipment which is used in the laboratories for almost all the subjects, including the projects. Whenever you want to see any waveform, the nature of the waveform, irrespective of it is a linear, non-linear, repetitive, non-repetitive, whatever, right? We would like to see that. For that purpose, we use this digital storage oscilloscope. But there is a problem here. The problem is how many waveforms at a time you can display is only two. Right? There are CROs which are available 4 channels, but it's very expensive. Even this one will cost you not less than 60,000 rupees. And a little bit bulky also, dimensions wise, weight wise. This is one problem where generally we notice that providing every student one CRO is an expensive option. And the second is it is not easily carryable because it has size and weight. Okay. And what is the second problem I said? It is about the number of waveforms at a time you can display on the screen is only 2. Okay. That means if you want to compare, you can compare only 2 signals simultaneously. Okay. That's the one equipment. Second equipment is, as you can see, what is called as a function generator. Okay. Function generator is the one which will generate the waveform, right? This is the output. Whereas in a CRO, it is the input, right? You would like to monitor the signal. whereas in function generator it generates the signal. Now function generator, where as the name says function means different types of functions. Nature of the output is available here. What type of output signal you want to generate, right? That you can choose with the help of these buttons. Would you like to generate sine wave? Would you like to generate square wave? Would you like to generate triangular waveform? So function generators are available. These three types of waveforms it can generate, right? So when you want to generate the waveform, what are the options you are looking for? A, type of waveform. B, amplitude of the waveform. C, frequency of the waveform. So whenever you want to generate any waveform, you would like to have the options on the function generator. You would like to change the amplitude, you would like to change the frequency of those signals which are generated, as well as the function. Then the other issues are, whenever you are generating a waveform, the polarity of the signal, right? Positive peak, negative peak, or would you like to shift it? Would you like to add some DC component in it? That is called offset value. So you would like to add some offset value to the incoming signal, so that you do not want to have the signal of negative polarity. Everything you want to uplift on the above the zero axis. So those are the options you would like to have on a function generator. The other thing is, I thought of saying something. Yeah, frequency range. What is the maximum frequency a function generator can generate? Say, for example, in this case, it says that 3 megahertz. So 3 megahertz is the maximum frequency it can generate. So anywhere between 0 hertz to 3 megahertz, you would like to have a variable frequency. All right. So this is again a most commonly used equipment in the laboratories, because you would like to have a reference, right? A reference waveform to be generated, so that whenever you design any circuit, you require an input to the circuit, right? Some waveform you would like to give it, or some pulses you would like to give it, like for example, a counter you have in digital electronics. You would like to generate some pulses and with a variable frequency. So this is what, that's why it's called as a test equipment, because it will generate the reference signals. But again, you have seen it's a little bit bulky, heavy in size, uh, and the waveforms it generates is fixed, right? The nature of the waveforms, that is triangular waveform, sinusoidal waveform, or these digital waveform, right? Pulses. Cost wise, it's not less than 12 to 15,000 rupees, right? So this is another, if not very expensive, but expensive, and a little bit heavyweight. So this is the second most commonly used equipment in almost every subject. The third is, of course, uh, any electronic circuit or any embedded systems, any cyber physical system work with power. If you don't give the power, none of them will work. Naturally, the system will start functioning only if the power is given. So how will you give the power, right? You have not designed any system for the power. We assume that power is there, right? We are supposed to give the power. But the power is not our conventional power, what we are getting, that is 230 volts AC. No. Almost all these components, electronic components, they are working on an amplitude anywhere between 0 to 5 volts, or at the most 12 volts or 15 volts DC. So you want to give a regulated, right, constant DC without having any pollution in that, no ripple on the signal, a pure DC as a reference. Then only you can, whatever the circuit you have designed, you have mounted, you would like to verify that. So as you can see, a heavy weight, I cannot lift it I mean, easily, not less than 10 kg weight. What you will have is, as you can see, these knobs, where you have 5 volts, 12 volts, 15 volts, at the most 30 volts, where you can output, you can adjust with the help of these knobs. Potentiometers, a DC output you can change. So it will indicate, right, what is the voltage and how much current you are drawing, right? So being a regulated power supply, whatever is the voltage you set, it will work. But as you can see, it is heavy weight. You can see, I mean, it's very heavy. Heavy weight because inside it has a transformers, step down transformers. They don't use the SMPS, what we generally use in computers or the electronic equipment, because the output voltage, what we want is from the linear output, not from the switching mode output. Because SMPS, switching mode output, will have some ripple in it. So that cannot be a reference for our most of the electronic circuit. All right. So a power supply anywhere between 3.3 volts, 5 volts, plus 12, minus 12, plus 15, minus 15 is the requirement for almost all uh, electronic circuits. So that is the third, which will cost you somewhere around 10,000 to 30,000. No? It depends on the quality of the output and of course the power ratings. That's the third one. Fourth, I would say, I mean, not always, but what is called as a arbitrary function generator. Okay. So what do you mean by arbitrary function generator? A conventional function generator will generate only a predefined waveforms, right? Only sine, triangular waveform and this square wave output. But a arbitrary function, arbitrary means arbitrary, means any waveform, a user defined waveform, whatever you would like to generate, it will generate. For example, ECG you want to generate, vibration you want to generate, or some earth signals you want to generate, earthquake signals or whatever, any type of waveform, linear, non-linear, anything you want to generate, it can generate. How it will generate? Through software, right? You are supposed to connect this to your computer by using this USB interface and then design your waveform on your computer screen and download it. Once you transfer it, it will display it here as well as the signal is available here. It is mainly used for in telecommunication as well as in these biomedical applications, where the signals which we are unable to generate from function generator, those signals could be generated by using these arbitrary function generators. So that whatever is, for example, I have designed for some biomedical ECG analyzer, but I require a ECG signal. Every time I cannot connect the probes to a patient, right? So 24/7 I want some signals, real-time signals. So those signals we can obtain from these arbitrary function generators, right? So the nature of the signal, the repetitiveness, the storage part, everything is possible in these user-defined function generators. Again, it is a very, very expensive, not less than 70 to 80,000 rupees. And you have seen bulky also. All right, so these are the generally used equipment. Otherwise, we know multimeter is most common thing. It's not expensive. Nowadays, every student is having a, I mean, in hardly some 400 rupees, you will get at least a reasonably good quality multimeter. So it's, I don't say it's a major challenge. But otherwise, also in every institute is giving students multimeters and breadboards. Okay. So, in short, in this pandemic situation, when students are not coming to the colleges, or even after this situation also, if students wants to perform any practicals or wants to build any products or projects, then the challenge is such type of equipment, right? The bulky equipment, costly equipment, they are not available to the users. That's the problem. So that means, as you can see, this itself is not less than 2 lakhs, this equipment. And then even in the engineering college, no, it depends on the type of college. Generally, no, these are all shared facility where group of students will be sharing these equipment. And I'm doubtful how many colleges are having arbitrary function generator or such type of equipment or these logic analyzers, those things where you can display the multi-channel simultaneously at a time. So these are some challenges currently. I mean, almost every student is facing availability of the laboratory. Though online, remotely they are studying, but the skill development is a major challenge. And if you look at the volume, right? If you look at the size, I'm sure every university is having 50 to 60 engineering colleges, and these branches are most common. These circuit branches are most common in every institute. And in a state, there are 300 to 400 engineering colleges. And at a country level, it could be around 10,000 engineering colleges, and maybe half equally polytechnic or diploma colleges are there. So, what are the total number of students? Not less than 10 lakhs of students. Because irrespective of branch of engineering, irrespective, including textile or no, metallurgy, first year is a common syllabus. That means every student must know about this equipment. Even in the industry also, as I mentioned, almost every industry there is automation. Every field there is automation. That means every branch, right, wherever they are working, they are supposed to deal with this kind of equipment. So if the students are not having confidence in using this equipment or analyzing these signals, and if you are only have some theoretical knowledge, not the practical knowledge, that is the really big challenge. That why our students are not employable, or the industry is not doing good, the core industry is not doing good, or there's no competitiveness worldwide because of lack of these skills. So these are some, I would say, the gaps we realized at our SPIT Product Development Center. With this, we thought, our management thought that, can we provide such kind of facility to every student? First at our SPIT level, then eventually let's see at how it goes to state or national level. So how to bring the cost of this equipment, right? This entire setup to few thousand rupees, affordable thing, and the lab. Lab means not only this equipment, right? You are supposed to provide some components, right, which are used for conducting those experiments, right? What are the subjects? As I said, BW, EDC, LIC, embedded systems or Internet of Things, and so on. So can we provide, right, all those things what generally are supposed to learn in these 4 semesters, right? Or maybe in electronics it may be 8 semesters, whatever. Can we provide this what is called as a mobile lab? There is a first problem, or I would say the idea for this session. What I'm talking about is the product design. Second level is that now since these things are remotely happening, can a faculty can remotely monitor what a student is doing, right? Because since it is academics, it's not only a project, it's also sometimes it's a part of academics. A faculty is supposed to go through the experiment, whether he is genuinely doing or not, and what are the results he has got, and is supposed to be get it graded in real time. So can we integrate this internet, right? Internet of things, because here things means our lab. This lab is a things. Now this should we put it on the internet, internet of things. Then this, if you integrate as a part of the computer networks, then remotely from anywhere in the world, this laboratory a student is handling can be accessed from anywhere in the world. A faculty can handle. So where this computer networks or internet comes into picture, and then capturing the data and analyzing the data and evaluating the data should happen in real time. So can we integrate some this what is called this learning, right? Teaching and learning methodologies into our lab, right? I'm talking about the ICT tools. So if we can integrate, then what is the volume? The volume is every branch has 70 students, and every student is having 4 to 5 subjects, and there are 70 institutes in a university, and then 300 institutes in a college, in a state, And in a country, there are not less than 15,000, including diploma colleges. So 10 lakh students data, 5 subjects, has to be in real time. I mean, I'm talking about the upper side. Can we capture it? Can we analyze it? And mm, can we provide the some solutions for that, right? So this is in short, I would say, the concept here or the idea here, that how can we help our to begin with our students in skill development, our institute in cost cutting and improving the skill set, and in short, the country, how we are, the society, how we can help in terms of availability of the resources indigenously designed as a nation. I mean, see, I'm sure not even a single company is there in India who is manufacturing these things. Even if they are manufacturing, they are importing the parts and assembling, or they are just only changing the labels on the parts. But otherwise, no, except the power supply part, most of the things are imported. And now, so in short, we are going to save the imports. That's what the economics part of this idea. All right. So this is my our proposal. Now, in the second session, we will see how this idea can be converted into the specifications. Right. I would say the design part. And once the design is done, then we will discuss about I mean, block diagram design is done. Then we will discuss about the circuit design. Once the circuit is designed, then we will talk about the prototyping. Once the prototyping is done, then we will discuss about the final deliverable things. So these are the various stages of any product, right? So who is the customer here? The customer here is our student. Okay. So that means now we need to understand as a student's perspective, not as a designer's perspective or a manufacturer's perspective. The user is he or she could be a first year engineering student. And a first year means a 12th passed out student. A 12th passed out student doesn't have the knowledge of any of the software hardware tools. That is a challenge, right? um, and a faculty is not in front of them. That is the second challenge. They are remotely working. We are not talking about final year students. We are talking about this has to be introduced at the first year, first semester itself. So those are the design challenges. So we have to discuss about those issues while doing the designing. All right, so uh, 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 this is my first part. In the second part, we will talk about the specifications part of it. Thank you.